Hey, welcome back. Another day of game design. So from this point forward in the semester, unless anybody's got something that they want me to cover specifically, I'm basically just going to work on my game during the week, and then the lectures will be me commenting and showing you the highlights of what I got done. So obviously we haven't had a lot of time since last time, so I only had about an hour to work on this. Actually, I literally had an hour to work on this just before class today. So not a ton for you today, but I did decide I would tackle the hard problems first so you can get a feel for some of these really tough ones. And I'm seeing my internet's a little unstable today, so let me know if the stream's cutting in and out, and I'll just swap to Discord. And we'll go from there if it's not looking good. No point in continuing otherwise. Always feel free to ask me for the source here. So the problem that I wanted to solve was that the built-in rigid body kinematic character controller doesn't face the mouse, it faces the direction that it's moving in. And I'm creating like a couch co-op kind of game here. So what I really want to do is this. See, I got it working already. But what I really want to do is have the character facing the mouse. And as he moves, you can move the mouse and you can kind of change his face direction. Later I'll get him to rotate more naturally and stuff like that, but right now I just care about him facing the mouse always so that you can aim. And then later I'll do the analog stick version too, so always facing the tilt of the right stick, which is what a lot of you are probably going to do for like your bullet hells and stuff. So first thing you might have noticed is that ominous yellow cube that's just hovering around. I like to do this whenever I'm working on hard problems. I like to build a debug object that I'll remove later on. So one of the first things I did was make this debug cube. He's an empty cube, just a mesh renderer, no collider, made of a unique color, yellow material here so that I can keep track of what's going on in the scene. And the first thing I did was locate where rotation is handled. And luckily, our lovely example kinematic body guy has some very great documentation. So what did I do? I kind of scrolled through to see where rotation's handled, made sure I read all the method headers. I've already read the 8-page documentation for it. If you don't RTM and then complain that you don't understand it, that's your problem. So if you're using this thing, read the 8-page manual and the message headers. It'll take you like half an hour. Come on. Anyway, reading through this brought me to this message header. Called by kinematic motor during its update cycle. This is where you tell your character where its rotation should be right now. This is the only, look at that bold upper text, where you should set the character's rotation. Sweet. After a quick glance at this, I can see that it's already slurping. I can see that I'll change the slurp time later on probably, but I don't care about that now. All I care about is that it looks like this is rotating towards something called look input vector, right? And it's making sure that look input vector has a magnitude greater than 0. So if I want it to not rotate on the frame, all I have to do is set the magnitude of the vector to 0. It uses square magnitude, which I think is faster or something than magnitude, so we tend to use it can't go negative maybe? That's what it is, yeah. So a vector's magnitude could be negative, but square magnitude is always positive, so it's better for quick comparisons like that. There you go. Anyway, so I looked around for where look input vector is set. That's where it's declared, and I found this switch statement that determines which orientation it uses. That'll determine what it faces towards. So I added 2 new enums for myself. I'm going to do towards mouse, and then I'm going to do towards right stick later. And then I went back to my player. I found the enums that I added, and I switched it to towards mouse so I could get started working. Okay, next point of business was going to be actually getting it to rotate towards the mouse. So at this point it's doing nothing. And here's what I tried first, all right? So let me go through what all of these do instruction by instruction, and then we'll kind of see what the finished product looks like. Also, let me know if this font is too small. I went back to the regular Visual Studio font, so if this is too tiny and you can't crank up the resolution, let me know. I'm glad to make it bigger. All right, this should be no surprise to anybody that we're going to need the mouse position. So I got the mouse position, but I should note that if you Control F in the rest of this class for input dot, you'll find that there are none, right? And that's because inputs shouldn't be handled here in the controller. This is a good practice that they put into the example script, and it's a practice you should keep up. I have all my inputs handled in the input handler, so when I'm done writing this, I'll move all the inputs to the input handler and pass them along the correct way. But for now, I just want to get it working, so cool. Alright, so I want to translate the mouse's position into a point in the world. So if we think about my mouse cursor flying around here, you'll notice that there's a yellow cube following my mouse cursor now for the finished product. Well, that's obviously what I want, right? But you'll also notice that the yellow cube, like, just scoots above walls and stuff, and, yeah, there he goes. I mean, that's a little strange, right? So, there he goes up there, he goes on top of the wall there. I mean, that is a little bit more advanced than just getting the screen point to a cube. We'll see what the actual difference is there. Alright, I'm going to save over this so my yellow cube will no longer work. I also linked my debug cube to this method, by the way, by creating a public game object debug testing cube up there. I actually don't need this camera anymore, but I'll keep it for now. That was for during testing. And now I can control the position of that cube, which is what I'm doing to see what it's translating. Alright, so to convert the position of the mouse to a point in world space, there is a built-in method that I'm going to use here. So we'll call this mouse to world, and I'm going to use the main camera, which is the only one that I have. So we'll do, there's a few options. You have screen point to ray, which we'll look at a bit later maybe, and screen to world point. So this seems promising. Now input is a vector 3, but the third magnitude is obviously 0 because the mouse only moves in 2 dimensions. It moves along x and it moves along y. So what do you need to pass to that third thing in screen to world point? Well, that's actually the height that you wanted to use for the camera that it's going to be projecting from. So generally you're just going to use the height of the camera unless you have a compelling reason to do differently. So here I'm going to do, sometimes you'll use the height of the player as well. I've seen that done too, but usually you'll use the height of the camera. So I'm taking the mouse's X and Y position, and then I'm going to take the main camera's height. So to get the main camera's height, I need the camera, main, that gets the game object that the main camera is attached to. Then I want its transform, then I want its position, and then I want its height, which is, I want to say it's y actually, right? So it's y. So I'm taking the x and y of the mouse and then the height of the camera, and I'm going to project a point into the world based on those 3 criteria. And Unity's going to handle the rest. Okay, let's see what this looks like. The first thing I like to do is to log it. This is before I even set up my debug cube. I like to log it and see what kind of coordinates I'm getting. And then we can go ahead and, from the previous methods, you can see what the look vector being set looks like, the previous items in the enum. So I'm going to do a similar thing, and I'm going to say vector 3 look at. I'm going to take the difference between the point that I found in world space and the character, normalize it because I don't care about the magnitude. You don't turn faster the further away it is or anything like that. You're just turning towards that direction, and then I'll start the look input vector in that direction so that the method later on can handle it. Okay, so I haven't added the cube yet. Let's see if we can diagnose what the issue is without the debug cube. This is the point when I actually added the debug cube because I was unable to. So we'll see that my guy rotates pretty well down there. Okay, I apologize for the cubes shoving him. And then sometimes he rotates up okay, but sometimes he doesn't. And then also he's kind of leaning back, which is not the intended idea at all. I don't want him to lean back towards the sky as I rotate. I only want him to pivot along that y-axis. And the quality of the rotation differs depending on what part of the screen I'm at. So down here it's really good, I guess relatively good. But if I go up here, it's pretty good facing down, but it turns crappy up there. I can't even look in that direction. but I can see him looking upwards somehow. So something's going on. This isn't being quite translated correctly. Oh, and then let's take a look at the console. Forgot about that. So let me unminimize, unmaximize on play. Let's watch the characters transform and then compare that to the points that we're getting in the console. So the characters at -9, -1, 2. Gosh darn it, cube, stop shoving me. Alright, the characters at -10, -1.5, -1. Down here I'm getting like -9, 1, 5, which seems right. I'm really paying attention to that z coordinate right now. I want to see if z is above or below the players. So down there's -8. That's more negative than the players. And up here is -4, -3, which is more positive than the players. So that works. But if I walk up to the top of the screen and try the same test, okay, down here is, I'm getting 9.1, which is way below the player's 29. And up there I'm getting like 12, which is still way below, so that's why he's not looking up in the z direction. He's just continuing to look down. And I can repeat that test for x, but it doesn't work as bad for x. It's z that's really the problem. Okay, so that shows me that there's a problem with how the point is being translated. This is when I decided I was going to add that debug testing cube so I could take a better look at that point than just printing it out. So let's get rid of the debug and actually check out the cube and see where it's at. I'm going to maximize the screen again first, and we'll see that the cube is floating pretty high up above the ground. This is looks like a consistent height from this angle, and when we get to the top of the screen here, we'll see that he is looking at the cube. The cube is just way above him. So the cube is perfectly following my mouse. Definitely mission accomplished on that front. The problem is that the player is way below where my mouse is relative to him. So I don't want him looking up into the sky at where my mouse is. I want him looking in that direction. So the next thing that I tried was to strip the y-axis away from that point that I got for the yellow cube and strip it back down to the player's position. So that's where this line comes in. Let's give that a shot. So I'm taking the point that I got when converting the screen to world point on the X and the Z, but I'm then using the player's Y position so that I ignore that cube being all high up. So now the cube should just constantly be at the player's height. Let's see what that looks like. Okay, well that works better in terms of the rotation, and this is really smooth, but it's no longer representative of the mouse's actual location. That's the problem, right? So the cursor's here, but my yellow cube is here. And actually, I could stop at this point, because when the game is being played, the cursor is going to be hidden, so the player will actually be able to adjust their perspective of what the cursor's like if I just draw the cursor as this yellow cube instead of the screen's true cursor. But that's a janky solution, because when I get to the top here, I actually have no way to look up there, because I have no way to get that high up. So, I said that would work, but I guess in practice it would not really work. It'd be pretty janky. But down here it's perfect when they become closer together. So why are they so much further apart up here than down here? Well, that's because if you look at how my camera works, my camera is at an angle, and so relative to this flat plane, the angle between the box made by my camera and the flat plane that's the playing area becomes more and more intense the further you get towards the top of the camera. So screen point to world space takes this, if you look at the end of the camera, basically this flat square that the camera makes, and translates that into a point as best it can, projecting a certain height away from the center of the camera. So in this case, the height. So imagine just a square right there at the camera's height that connects to all four of these points. That's what I'm getting, and that doesn't actually represent the plane beneath the camera accurately. But it would if my camera wasn't rotated. So if your camera is directly overhead, like some of the bullet hells, you can use these translations into world space much more effectively. And I guess that's what I was used to when I took a crack at this. So, all right, that was basically as far as I got. Then I realized, okay, that's not going to work. It works okay, and I might still be able to kind of clutch my way around it maybe, but this isn't the way to go at this point. That's pretty clear. So what I needed to do was figure out a way to get a point along the actual plane, along the ground. So if we think about where I actually want the character to look at, well, I want it to take your mouse position as you're hovering over some point on the ground. So any point on this black area that's the ground, I want it to look towards that. And if you're hovering over a wall or something, I don't want you looking at that. And that's the part I actually haven't finished yet, so I'll go back and do that in a bit. But how do I do that? So that brings us to, I guess, our main topic today, which is raycasts. So a raycast is an imaginary line that you can fire from anything. You have to give the origin, the direction that you're going as a vector, and then how far you want the ray to go. And you can just say go to infinity. And it'll draw a line from the origin in the direction that you would like. And what happens with the raycast is that you can say, when you hit something, let me know, and then you can fire off an event. So the raycast basically shoots out a laser beam, checks if it hits anything, and then if it hits anything, you can perform an event. But I want to shoot out a very particular laser beam. I only want to hit the ground. And I actually don't necessarily even want to hit the ground. I want to hit some very particular surface. So I actually made a new cube for that I called character rotation target. I made it invisible by turning off its renderer. And it's basically the same thing as the ground on this level, but on other levels, I might have it be, I don't know, beneath the ground. It might have different dimensions. So depending on how the terrain is laid out, I might not necessarily want you to always use the terrain to get your look perspective. So after I built this cube, I gave it a box collider and I set it to trigger because I don't want it to have any kind of physics or rigid body interactions. Then I gave it a new layer of its own, so I called it the player rotation target layer. I made the new layer, I set it to that layer. I'm not going to use a tag for this, I'm going to use a layer. And the next thing that I did was I went to my project settings, and I went to physics, and I made sure that the player rotation target layer can't collide with anything. So it has no physics interactions outside of what I'm about to do here with raycasts. This is a good way to handle different kind of triggers like enemy AI or events that have to happen. Like let's say you bump into a trigger and it's supposed to open the door. You can go in here and make sure that that set of triggers, so the door opener layer, only collides with the player and ignores everything else. And then you don't have to handle different tag checking and whatever. Now you have the physics engine doing it for you by just ignoring collision with everything else. It also improves the effectiveness of the simulation, gives it a little bit more efficiency because now it can ignore some collisions. Okay, so all that was before I started any code, though. Let's look at the code. So, the first step is to generate a ray. Once again, I'm going to access the main camera, and this time I'm going to do screen point to ray, which creates a ray that starts at the camera and is guaranteed to pass through a certain point. So rather than giving it the direction to go into, you're actually giving it a vector in 3D space, and it'll guarantee that if the line didn't bump into anything, it would pass through that point. So if you think about it conceptually, that's the same thing, right? If I give you the origin and then another point in 3D space, you can always draw me a line. So that's far easier than having to give you like a direction. So that's how you give rays a direction. You just give them another point in 2D space or 3D space. So screen points array, the point that I want to give it is the mouse position. Remember, the z-axis part of this is 0, so that's fine. It's going to create a point that goes from the camera to that x and y location and then continues onwards. What you get when a raycast strikes is called raycast hit. I like to instantiate it as an object. A lot of tutorials and stuff don't, but whatever, this is a preference thing. And then I wanted to ignore everything else in the scene that isn't that new layer that I created. So for that, you want to make a layer mask. Layer masks are really only used during raycast collisions and other physics events like physics overlap sphere and overlap cube. But they're really useful for when you want to ignore certain layers for your physics events, or vice versa. In this case, I only want to have the raycast targeted on this layer. And there's something slightly wrong with my syntax here. I'll check it over later, but approximately you do this. So you want to take the layer. You can either just give the layer number like this, so I know that it's layer 6, or if you want to be more not magic numbery good programmer, you can use the name to layer function and give it the name dot layer. And I really shouldn't be doing this in update. I should just like set it as a constant somewhere too. So I'll go back and fix that later as well. But this gives me the number of the layer named player rotation target. Okay, so now that I have my ray object, my raycast hit object, and my layer mask, I can initiate the ray. So to initiate a ray, you want to do if physics raycast, and then you supply the ray, you supply the output and where it goes. So mine's going to that hit thing. You supply how far you want it to go. I think it's math f dot infinity for an infinite distance. Yep. And then you can supply the layer mask. So if I supplied it like this, that would be telling it to ignore that layer, which I want to do the opposite, which is the little tilde here. So layer masks all operate under bitwise operations. So if you wanted to add like another layer, you would have to do and it together like that. If you wanted to add a bunch of layers, I think you actually have to bit shift the different layers together like that. So make sure you look up an example of how to do it with multiple layers, because it's not intuitive. But the Unity documentation is great for that. So if that's something you need to do, just look up the Unity documentation for it. All right, first let's just draw this, and so we can visualize what it looks like. I'm gonna debug draw line ray. Oh, actually I need 2 points, so we're gonna do ray origin and the point that the ray strikes, which is hit point. Okay, and I'm going to not maximize so that we can watch the camera fire some laser beams at the scene. So as we can see, there's just one continuous laser beam. Because we're doing this in update, it's just firing that laser beam nonstop. Now, raycasts are not necessarily expensive, but when you get into having like more than a dozen of them in one frame, they can be. Using them for inputs is a really good idea. Using them for your player is a really good idea. Using them for all your enemies and stuff, that can start to be a little bit too expensive. So try to limit the number of raycasts you do if possible, but don't be afraid to raycast an update if you really need it. And again, we discussed last time IA enumerators, coroutines. It's perfectly possible to raycast inside of a coroutine, but in this case, it's for rotation. I want it to happen as fast as possible. Okay, we noticed that when the laser beam passes through something that's not on the layer mask, it should stop. So let's look at this wall, and you'll see that my layer mask is definitely set up incorrectly, because as it strikes this wall, it should just pass right through. So there's something wrong with my layer mask, because that layer should be ignored. So I'll fix that later, but hey, good enough right now. Continuing then, we're going to check the hit spot. Could just use hit.point, don't actually have to save it to a variable, whatever, it's just my preference. And I'm going to put the debug cube down there. Okay. And then I'm pretty much done. I'm just going to have you look towards it. So let's say vector 3 look at equals, and then I'll do the same thing I did before, where I take the normalized vector between that point and the player, and then set the look rotation. Let's see what that looks like. It's, spoiler, going to be pretty good. Let's make it full screen too. Alright, so there's my yellow cube, and there's my guy, and he can now look very accurately towards the yellow cube at any point in the screen, which is great. Since my raycast's a little busted, I can do something like this, where he looks towards the wall, and that's not necessarily bad, but I don't want that behavior, so I'll patch that out later. And again, like up to the top of the wall here. But otherwise, really good. So there is a little bit more code there, if you notice. What's that little bit more code for there? Well, I noticed an edge case, right? So when you're looking around like this, everything's peachy. But what if you smack the player? Yeah, that's not, that's weird. Yeah, so I don't want that, do I? That's just odd. I don't want him to, like, start leaning when he gets struck by the cube. And makes for some pretty weird effects when you do it and then go off. Anyway, not what I want. So how do I handle it? Well, the simple answer is I could compute the distance between the player and the hit point, and I could not do anything if the distance is small enough. I tried that, and it was tough to get an accurate bead on the distance because sometimes, due to the camera's position, sometimes the beam lands in front of him, and sometimes the beam lands on the opposite side of him, and the distance is a little bit different in those two circumstances. And also, if you use distance, it feels kind of unnatural because you have this dead zone around the character inevitably where you can't rotate. So I decided on another solution. What I did was I went back to my player character object, and I gave him a child cube called ignore rotation target that I put on the same layer, and I tagged it as player. And this thing I also turned off the mesh renderer, gave it a box collider, set it as a trigger. Rays don't have to hit triggers. I believe they can hit regular colliders too, but if you don't need physics, just make it a trigger. Why not? Okay, so this guy is inside the player, and you'll notice that if it strikes this cube that I put as a child of the player, well, then it can't strike the rotation target that's part of the floor. The player is always above the floor, so the beam will always hit that first. Let's kind of confirm that. Minimize, find the rotation target, play, and watch the beam get consumed when it strikes the player. Hard to see because he tilts his stupid face up. Okay, cubes, back away. Alright, here we go. Well, that's tough to see. You'll have to take my word for it, or maybe we'll look again in a bit. So what I want to do is, if the laser hits the player rather than the floor, then I'm going to do nothing. And that's simply if the thing that's being hit, so not the hit point, but hit actually returns the object that you struck, as well as stuff like the point information. So hit is a class that has info about the vector in space that you hit, and then a few other things, such as the actual collider that you made contact with. So I want the hits, I want to compare the tag, and I want to see if it's a player, which is what I called that tag. And if it is, then I'm going to set lookat to 0, and remember, the way that this thing works is it checks the square magnitude of that look vector, and if the square magnitude is 0, it does nothing, so this has the effect of making it do nothing. And I also printed a debug here, just to be sure. And if it hits anything else, so the plane that I actually wanted to look at, then it will actually adjust its look rotation, and that gives me the finished product. Whoops. There we go, and regardless, this line happens, so that doesn't have to be part of the else, that happens in both. Okay. And let's play it now and watch what happens when the beam strikes the player. Nothing. You see the cube just hovers over it, but he doesn't rotate anymore because we don't rotate when we hit that plane. And you see that the beam stops. You no longer have to take my word for it. It doesn't continue. Now you can also make raycasts that continue. Oh boy, I made a bug. I'm trying to compare it to something that doesn't exist because I screwed up my layer mask and it randomly struck a bullet. So another reason why you want to get your mask working, because I don't want to hit other things in the scene because they might vanish, be destroyed or whatever, and that could create defects. So I'm going to have to get that layer mask working for sure. All right, any questions on rays and looking towards rays? This is kind of as far as I got today. Next up, after I fix the masking issue, is going to be to get my guy to melee attack, which is also going to be done probably with something in the physics package. All right, rest of the time today I will go through and see what all the different teams are doing, see what you guys need, so head into Discord and talk to me, let me know how you're doing. Let me know what else you need to make progress, especially when it comes to assets and such. And also, starting at the 8th, which was yesterday, Unity is going to have a couple flash sales on assets every day. So make sure you check back on the asset store. See if there's anything you need and put in a request if it's something that might be useful to you. All right, see you next time.